In example 3, we already have nice, neat factors in our denominators. The first factor is the bracket factor, x plus 2. The second is the bracket factor, x plus 1. And the third denominator has an x plus 2 factor and an x plus 1 factor. As I already have all my factors fully factorized, I can write down my LCD. My LCD is the most of each type of factor. Well, there is only one x plus 2 factor in any particular denominator, and at most there is also only one x plus 1 factor. Now that I have my common denominator, I can write it down for the whole fraction. Also, I can write down my restrictions. And so if x plus 2 cannot be equal to 0, x may not be equal to minus 2. And if x plus 1 cannot be equal to 0, x may not be equal to minus 1. Now going back to my sum and finding my new numerators, the first fraction had a factor of x plus 2. So it has now got to have its numerator times by the new factor in its denominator, which is going to be the one that had been missing before, x plus 1. The next numerator has a new factor of x plus 2, and the last numerator had one of each factor that is in the LCD, so there is no new factor that needs to be put with the old numerator, and so I just write down the old numerator as it had been before. Multiplying out my numerators, I get 2x plus 2 minus 3x minus 6 plus 2x plus 5 all over my common denominator. When I add the terms in the numerator, I find that 2x minus 3x plus 2x is going to give me x, and when I add my constant terms, I have plus 1. Now you might note that if I put a bracket around the x plus 1 in the numerator, that is going to be an identical factor to the x plus 1 in the denominator. And as I no longer have any terms whatsoever, the x plus 1 factor in the numerator can cancel with the x plus 1 factor in the denominator. And so fully simplified, my fractions actually add up to a very simple fraction of 1 over x plus 2.